A very good afternoon to all of you. Welcome to this second lecture of this course that is on basics of geocomputation and Geoweb services. The title of today's lecture is Open Geodata Repositories and ISRO Web Services for Thematic Applications. The content of this lecture session will be as follows. I will be telling you about the Open Data Repository. I am also calling it as ODR. Where are the different types of data repositories and what are the mode of data access from ODR? In which way you can get data extracted or data access from an open data repository? What are the key features of data? This open data repositories, and there are few challenges also in ODR, and some examples of data repositories from ISRO and other special other government agencies, or there are other federal other agencies which are providing the open data repositories. Then I will be also telling you, I will giving you a demo on data access from ODR, basically from OpenStreetMap and one from the Bhuvan Geo portal. So if we talk from the starting over here, so what is an open geodata repository? So before going into an geodata repository, let us talk about a data repository. So we can say that a data repository can be defined as a place that holds data, makes the data available to use, visualize and analyze. So there are three key terms which are used in a data repository. We should be able to use it, we should be able to visualize the data online itself, and we should also be able to analyze the data set. So there should be some mechanism wherein without downloading the data I can analyze the data on the fly itself. So these are the basic features of a data repository. Now it is also a place where the researcher can submit their data sets. Now the data repository which allows receiving and reproducing the data by or from anyone is termed as open data repository. So there are different types of data repositories. It can be a proprietary, which only gives the access for the data visualization and usage, but it does not allow you to download the data or reproduce the data. So they are termed as a proprietary or some specific data repositories. Whereas the data repository which allows you to receive the data and to reproduce the data in any form by anyone, then it is known as a open data repository. Now if the data is geospatial in nature or it has the spatial characteristics, yesterday I think it was told in the previous lectures also, the data which stores the location information with it, that is known as a geodata. It means the data is having not only the attributes, but it is also having the attribute of its location, which place it belongs to. So that kind of data. So if your data is, if your repository is holding geodata repositories, then it is termed as geodata repository, and if it allows you to receive and reproduce the data, then it becomes open geodata repository. As simple. Now there are different types of data repositories. First, if we talk, we have a data warehouse. It is basically a large data repository that allows aggregate data. Aggregate data means in some way you have aggregated data with respect to the time or with respect to the spatial boundaries. Example, let us take one data set. You are having a climate data or a weather data. You are getting a daily weather data, but you are producing the 8-day product. You are making an average of 8 days, and then you are keeping it in the repository. So that is termed as an aggregated data. Or if you have the data of the entire district at each and every place, but you are giving it in the form of district wise, the whole one value for the entire district or one value for the entire village. It can be any boundary. It can be in the time domain or it can also be in the spatial domain, both the data. So in that terms it is known as an aggregate data. In aggregations most of the time we are using the three parameters are there. First one is the maximize, it can be the majority, or it can also be the average. So these three parameters can be used within that boundary or within that time period. So our data warehouse, it is a large data repository that aggregate data usually from multiple sources or segments of a business without the data being necessarily related. So the data need not be related to each other. It is a big warehouse kind of thing, a storage wherein we are having the data from multiple sources. So these two terms are very important, becomes important over here. We are having the data from multiple sources and they need not be related as well. So that if the data is in that form, we can call it as a data warehouse. That is a superset of all the repositories we can call it. And similarly, if we talk about the data lake, another term which are commonly used in the data repository, it is a large data repository that stores unstructured data that is classified or tagged with the metadata. So if you are having a huge amount of unstructured data means it can be a file, it can be a photograph, it can be a data from the social media. So the data which is basically not structured, there is no particular structure of it. Like you are storing the data in a database management system, so it has a particular structure. But if your data is in not that form, it is just raw data is coming to you. So that and it is tagged with the metadata, then it becomes a data lake. Okay, and similarly data mart. So if you say it is nothing, it is just a subset of a data repository to a specific domain. These data marts are more targeted to what the user needs and easier to use. Basically, these data marts are also more secure because they limit unauthorized users to isolated data sets. Those users cannot access all the data in the data repository. So it is creating some sorts of boundaries. So if you are creating the boundaries, okay, this data set is available for this particular user, this particular data set is available for some another set of users. So these kinds of boundaries are created. So in that form we are storing it, then it becomes a data mart. Similarly, if we talk about the third term, that is the metadata repository. Basically, metadata repository, it stores the data about the data. Okay, what are the properties of the data, who has created that data, when it was created, what is the time stamping of that data sets, and these metadata, basically it explains the data sources and how it was captured and what does it represent. Rather than containing the actual data, it is only telling you about the data sets. What is it actually? Now the new term is coming up in the geospatial domain. We are calling it as a data cube. So data cubes are the list of data from 3 or more dimensions stored as a table, and you can, like for example, you can find them in a spreadsheet, in an Excel spreadsheet. You have multiple sheets are there in a single workbook, you can say. So this entire workbook is a very abstract representation of a data cube. The same thing we can have in our spatial domain also. In our coming sessions, I think we have one lectures also in which we will be telling you about these data cubes, and we will having a hands-on exercise as well. There is one very popular data cube that has been created by Google. We call it as a Google Earth Engine. That comes under the category, we can say that comes under category of data cube. It is providing the multi-dimensional and multi-temporal data set. A ready to use data set is available over there. So we have a separate session for that data cube exercise also for you in the by the end of this course, at the end. So I think you will be enjoying that part as well very much. So now let us talk about the modes of the data repositories. How we can access the data sets from the repository. Whether downloading is the only option over there? No. Apart from downloading the data through HTTPS or FTP method, herein we are downloading the physical data into my computer, and then I am utilizing it, using it for my analysis purpose or by research purpose. So this is not, but what is the limitation with it? It may be possible I have a huge data set available in a data repository. By my computer there is a very less space, so that limitations comes into picture over here. I cannot download that data into my PC and then use it. So whether there is any mechanism so that I can use the data from that repository itself. Yes, that is also one possible over there, that we call it as a APIs or the web services. In very popular formats of web services are WMS, that we call as a web mapping services. There are web feature services also, and web coverage services also. So these are three basic mechanisms wherein you can access the data from remotely also without getting it downloaded to your PC. So you can directly use it over there. And also, suppose you want to create some data online, so that can also be created in online mode as well. So if you see here in the download format, we have the save files. In geospatial domain, what kind of data we download? One very popular format is save file. This is one vector data format which people usually download from the internet for their usage. Similarly, we have the GeoTIFF also. That is one raster data model, means the grid or the images are there. Similarly, we have one HDF format is also there, a compressed format, huge data set storage for, and similarly we have one NetCDF data sets also. So these are different formats from which you can download the data set. I will give you a small demo also wherein you can download this data set. Similarly, for consuming the services, this WMS, WFS or WCS, basically this WMS is nothing but it is only a portrayal service. It will show you a snapshot of the data which is available in the portal. Only picture you are seeing it over here. You can screen capture it, but what it will do, in whichever portion you are zooming it, that portion will be made available to you as a small JPEG image or a PNG image that is available. Similarly, if you want the actual data set, then we have another format that is called the web feature services or WFS as well. Okay, now these are some standards which are defined by one consortium, is their global consortium by the name called OGC, Open Geospatial Consortium. So that has defined these standards wherein these repositories are making use of these standards to make the data available to your PC in the form of web services. Okay, so this web feature service is basically for the vector data, whereas this web WCS, web coverage services, these are basically for the raster data as a service for you. So both the things are there. So you can directly link this save file with WFS, whereas GeoTIFF file with the WCS. Here you are downloading the data, here you are accessing the data from remote data repository as well, and you can also create your online data sets as well. Now, some of the key features of open data repositories. What can be the features? Okay, that questions comes to our mind as well. So availability and the access. So the open data repository, it should allow you to make the data available as a whole and at no more than a reasonable reproduction cost, and preferably that is the downloading speed or the consumption of the internet data sets over the internet. Only that much cost should be involved into it, and the data must also be available in a convenient format and modifiable form also. It is not that I am downloading the data and I am not able to use it. It should be convenient to download as well as convenient to use and modify it also. So this is one important property of an open data repository. Similarly, the reuse and redistribution. So the data must be provided under the term that it permits the reuse of the data set, redistribute the data including intermixing with other data sets also. The data must be machine readable as well. So this another feature of an open data repository. Similarly, if we talk about the third property, that is universal participation, it should be like without any restriction. It should be allowed to use the data. Everyone should be able to use the data. They are able to redistribute the data, reuse the data, and there should not be any kind of discrimination against the field of endeavor or against the person or a group. For example, non-commercial restrictions that would prevent commercial use or restrictions of use for a certain purpose like education. These things are not allowed. Now this open data comes from a variety of sources as well, typically from the government, but it also includes data generated from the research. So these are few key features of an open data repository. If we talk about the challenges, what can be the challenge in an open data repository? So data licensing, how to define the licensing of the data, okay, how to protect the intellectual property of the person who has created the data. Like the second becomes interoperability. There are different formats of the data in the open in the open data repository. One data repository is providing a data in X format, another one is providing in some other Y format, and how these data will exchange with each other or how they will talk to each other. So interoperability should be there. So this is basically attained by this web service concept which I was telling you earlier. So that allows you to mix the data, one set of data with another set of data set can be mixed with together with each other. Similarly, what should be the policy of the data mishandling, if any, how the data can be mishandled. So these are some challenges. Scalability, who will improve data, whose responsibility it becomes to increase the data set to another dimensions. Similarly, the quality also, because it is coming from the open data and everything is free of cost over there. So quality also becomes one challenge in case of an open data repositories. Okay. Now these were some of the key features of open data repository, some challenges I told you. Now let me give you one examples also of some open data repository. One very popular open geodata repository is your OpenStreetMap. So it is providing a wealth of data on various kinds of boundaries are available over here, various kinds of features like road, building footprints, forest boundaries, even geological data set, river boundaries, river data set, hydrological data sets. So a wealth of data is available in this open geodata repositories. So this all data is available in the form of a vector in a vector data model kind, as a vector in a vector format. So now these data sets can be just let me give you the live demo also. Let us take one task. Suppose I want to download the building footprints of a particular institute. Let us say there is one institute. I will take one example. Let us take Doon University, or it can be a petroleum university, or even IIRS also. Now I wanted somehow I want the building footprints of all the buildings that are within that administrative academic area, either Doon University, or it can be a Uttaranchal University, or even the IIRS. So I want the building footprint. So and what is the road network within that academic area. So these two data sets I want to download over there. So just let me give you an example of it. So for that we will be using this QGIS software. Okay. So this is also one very popular open source software that might have been covered in the previous lectures as well. So here I will use the same software to demonstrate you of data access mechanism through this open geodata repositories. And one popular I selected, that is OpenStreetMap. So if you see it here, you need some plugins also for getting the data set into your QGIS software. So I will go to the plugin and then I will just say manage and install plugin. It will fetch the repository of the plugins here. Now here you can just in the search button you can type quick OSM. So this is one plugin which is required. So you just select it. There are other mechanism also. You can directly download from that OpenStreetMap websites as well. But since you are already familiar with this QGIS software, So here you can directly visualize the data sets also. All a wealth of features are available in this software, wherein directly you can download the data and then visualize it also and do what kind of analysis you can perform. So that's why I have chosen this QGIS software with you. So this Quick OSM plugin is there. Let me install this plugin. So it will install that plugin. Okay, then you can just say close. So if you see here, you will have that plugin in vector over here. This is one menu item called vector. Here I am having this Quick OSM. You just click on this Quick OSM and I want to read the copy. I understand, you can just select it. Hey, I understand it. Now here this is one interface it will provide you. Now here I have selected that I want the building footprints. So what I will now it says here you can type the keywords over here. I will say buildings. So it is already giving me the keyword over here, buildings. You just select it. So it is showing some filters also, what kind of filters you can add. So for the meantime, what I will do, let me remove all these filters. I will take all the types of buildings. I am not applying any filter. So you can just click this minus button and it will remove all those filters. Okay. So I will say here I on all the values I want of the building. So but before going into that part, what we will do, let us try to load this OpenStreetMap over here. Okay. So first what we will do, if you can see here, I am going over here, then there is one on the left hand side, I have one panel over here called browser. If this is not visible to you, just go to this view over here and then at the bottom we have the panels and then you can select this browser. It will be visible to you over here. I am using this, you can just check it here, QGIS. This version is I will just randomly I have used it. I will open it over here. So it is, you can just check what is the version of the QGIS, about QGIS. So it will show me yes, this version is 3.26.2. okay, this is the QGIS version which I am using. I think there may be some interface difference in other versions also. So here if you see on the browser, you are having many options are there. There is one option called XYZ tiles. You just switch off expand this XYZ tiles and then I have OpenStreetMap over here. You just drag it to this canvas over here. So the OpenStreetMap is visible to you over here. Okay. Now you can zoom it further. Now if I am interested in Dehradun region, so I will zoom it to the Dehradun part here. Let us say this is your Dehradun state over here of India, and then in Dehradun I will further zoom. Now let me take Forest Research Institute, anyone we can take. So now if you see it here, there are certain buildings footprints over here. This is your entire building entire boundary of your Forest Research Institute. This is some forest boundary over here. Some data set I am able to see here. These are some building footprints as well. Now what I want to download these building footprints and use it for my some specific analysis. So how to download these data sets now? Now again you go to this vector portion over here, Quick OSM, just select to Quick OSM which we have done earlier. I will just type it here, buildings, okay, and then let me remove all these filters from here, key values I want for all. Okay, so where I want, if you see the first option is the preset, you have selected buildings over here, and in, if you see the canvas extent, there are multiple options. First is in, second is around, canvas extent, layer extent, not spatial. Canvas extent means whatever extent is visible in this canvas, so that is called the canvas. So I will take the canvas extent and then I will say run query. So you can say it is downloading those data sets for you. So yes, some data sets have been downloaded. If you see it here, this much data set it has downloaded. So it has downloaded a huge amount of data set. What I will do, I will switch off this OpenStreetMap. Now if you see it here, it has not only the building, but it has given me some lines and some point data sets. These are of no use for me. I am only interested within this boundary and this building footprints only. That's it. Other data sets I don't require. So you can simply edit it here. You just click on this. First of all, you can switch off. It has given you the data in multiple formats. So first I will take only the polygon feature. Polygon feature, you can directly, if you see here, toggle editing, you can toggle edit here. Now what you can do, you can just select the data sets from here. If I am selecting it this boundary, I am not interested in this boundary. Here also I am not interested. I am only interested within. You can just delete it. Select it and delete it. Okay, this polygon is also not required. Just select it. It can be deleted. Now if you see it here, let me zoom it further. I think this QGIS you may be familiar. So there are some other, these footprints are coming over here. So there may be some building footprints as well. This is some stadium building. So I can again OpenStreetMap I will switch on. So if you see it here, these are small polygons. You can just check it also. There are some houses. These are all building footprints. So these are available to you over here. So now I am getting the data set over here. This is not a building footprint. Select it. This is not required here. Then there are certain other polygons over here. This polygon, I think you can check it here whether it is required. Yes, it is a football ground. So you don't require a football ground also. Select it, delete, you press. This also select and this delete. This is some patch Rashtriya Indian Military Academy. This is coming out of your forest boundaries. So this particular polygon also not required. You can delete it. This polygon not required. This is also not required. If you see it here, you are getting this particular building. So I am switching it off. So this building, if you delete it, select it and then delete it, so you are getting exactly this building. This is the building, Forest Research Institute building. This one I wanted. Select, delete it. This is also not required. So you can do small of editing also over here. Delete here, delete. These all are also coming out of my area of interest. So you can just simply select them and delete. Okay. So only the boundaries which are, only the footprints which are coming into my area of interest, I will select them and retain them. This also, these are out of my area. You just select them, delete it, select, delete. This is also out of the boundary. Select, delete, delete, and this is also not required. Delete. This is also not required. So these buildings are also out of my area. So these can be selected. Similar, very simple method. Select and delete. So only these buildings are required. So you can delete this also. This is also not required. This is also out of the boundary. So only these buildings are there which are required. So you can just see here. This is also some noise over here. This noise. So only these data sets are required which are useful for me. So again I will select this portion over here and delete it. So only buildings are required. So this is also not required. This is also not required. These are some buildings basically over there. So now you can directly save it. Right click, toggle editing. It will ask to save it. Yes, save the buildings. Right click and then you can save them. Save layer as. You can export. Save features as, and then I can save them in whichever format I want, like ISRO save file, and file name I will give FRI underscore BUILD and building footprint. Okay, so you select it. It will taking the projection system also, that is 4326 WGS 84, and then if I click OK, so your file will be saved as a layer. Just remove it here from this. Yes, I am removing it over here. Now only the building footprints I am getting. So I have just cleaned the data also. Similarly, this lines data set, you can check it here. This is one road data set. Okay, so this is one single line is coming. You can just check it. What is this data set? So this is one road which is coming, but this is not required for me. So I will just ignore it. we can remove this one also from here. Okay, and then another line is also there. You can just check what is this line. This is also of no use for you. You can see it here, multiple rows it is showing. Okay, so either you just clean it and then use it for your purpose. This is one row data set. You have to remove all these data sets and then save it. So that can also be saved as a row, and these are some point locations. You just click at one point, it will show you what is this data set. There is another icon called identify over here at the top, identify feature. Just click on this point and it will show you what is the attributes of no feature at this point found. Just zoom it here and then I will try to click it here. I will select that layer first of all, select that layer and then click on this. So it is showing it is some point with some attributes, but it is a suburb. Okay, or in name is Kalagarh. So if you can see one more thing over here, right click on this property. Let us take this building footprint only. Right click on this building footprint, and if you see open attribute table, if you open the attribute table, you see you have a number of attributes. Geometry we have edited. Similarly, you can edit these attributes also. There are multiple attributes, but some of they are not having any values with them. Only in type I am having some values, name I am having some values. So here also some values are over here. Now the same way we have edited your geometry, the same way we can edit the attributes as well. So just click on this particular portion over here. This is toggle editing over here, and then you can click delete field. Which fields you want to delete? You don't require this opening HO. Opening HO, select this. This is not required. Government, because these all are blank, so we can just select them and delete. Address house, ELE, there are multiple because some of the things are not required. This is roof shape, water. So if the values are there, you can retain them, otherwise you can just delete them. Okay, so you can see some of the attributes are now deleted. So this is the method of editing the attributes. So you can delete all those things here. Let me delete it also. I am just deleting it here from last. Let me take it here. Layer is not required, name is required. Okay, address city, yes, it is required. Postcard is also there. Address street is there. Some values are there. Short name is there. Land use. So I will just off it here. So you can just see here. I will just remove this land use of wiki is not required. Type is not required. And you can see here land use. It's only land use I will take. Let me try to remove land use, boundaries, name. There are multiple features, name, UR, amenity, grades. These, because these features attribute does not have any value, so I am just removing them from here. Man-made, natural, leisure, sports. In some of the cases, the values may be available over there, so that you have to see whether values are there or not. So only few attributes now I am retaining. Okay, so you see some of the values are there here in the Wikipedia. Some values is written there. In the type also multiple polygons. Short name, only one polygon name is there. You can further edit them as well. Now let us say I am knowing what is this hostel. You just click it here, and there are certain features over here. Select this building. I will just select that building from this select option over here. Select it. I will just see what are those buildings available to me. Zoom to layer we will select, and let us say this building. Now if you see here, it will get selected over here as well. So selected feature. So this is your selected features, and you know what is this building from the ground. You can just simply add to it. Let us say sports complex, indoor sports complex. This is one building. Indoor sports complex, some values I am giving. So you can not only remove those attributes, but you can also edit the values of the attributes. So this is one small mechanism. Save it. Yes, so your data is now little bit cleaned also, and you have given some values to this data set. So this is one method. And similarly, if you say I want the road layer as well, so you go to this quick OSM over here, and then you can see here highways, HIGH, highway. So there are many highway, so I want to select only highway. So there are multiple filters are there to it, but we also have only streets I want. Okay, so there are this, you can remove all these filters from here. If you want any particular filter, you can retain that filter and it will keep that also. Canvas extent is over here, and then run query. So you will have the streets data sets. Okay, so I don't need this. You can, it is downloading multiple values with you. You can remove all these things here. This also I can remove from here, remove layer. Okay, and this earlier I have downloaded this one, so this can also be removed from there. Now this polygon also I don't require, you can remove it from there. Okay, and only these layers I want, and then I need to clean these data sets. If you see, it has downloaded a huge amount of data sets. You can just clean them, just toggle the editing and do the editing over here. These rows only I want. So what you can do, switch it off, right click here, then you can say again toggle editing, and then keep on deleting this layer. Like simply you can delete. It will take a little bit of time, but in the one go you can select it and you can download all these extra road layers which has come up over here. So this way, so only these boundaries you can retain. Then we will see it here, like see, select it here, delete, just zoom it down and delete it here, delete this layers also, delete this layer also. Now I can just remove all these data sets, because these are all only noise data sets for me which has got downloaded. So but I am only interested within this portion only. So we can remove it here. So all the noise data will get removed, and here I am having all the data sets which is required by me. So if you see it here like this, now you can just save it here, right click, toggle editing, we can do here toggle editing, yes, and then save them as road. I will save that, export, save feature as, and then here I will say some name I will give to it, FRI building FP, and then say I will say FRI building underscore here one roads name, ROADS, roads I can give it to it, save it, and then okay. So your roads are also now saved. You can see the attributes also of these roads. Open attribute table, so it has certain attributes also. These attributes can also be edited in the same way I had edited the attributes of building footprints. So I am just leaving it over here. So you can just see here what kind wealth of data it is showing. Like if you see here, open street map, and there are numerous amounts of data sets. If you see all the features like annotations, buildings, apartments, and then craft, you can also have the data sets from historical. I think if you see here HISTO, historical places and objects, or let me talk about geomorphology, suppose geography, okay, land use, let us say LAND, land use. So land use and nature, land use and nature land use. So numerous data sets is there. You just try to explore this data in QGIS for your area of interest and try to use them. Okay, so this was one small demo on your open data repository from OSM, that is OpenStreetMap. Now if we move further, there is another, this is not from ISRO, but that is a crowdsourced geodata repository. Similarly, let us try to take another example from ISRO as well. ISRO also is maintaining one geodata repository that is by the name called Bhuvan portal. Okay, so I will just go to the browser over here. Now if you see, I have already opened here. The URL for this repository is bhuvan.nrsc.gov.in. okay, it is written over here, bhuvan.nrsc.gov.in. Now if you see here what kind of data it is providing. Now I told you earlier also in an open data repository you should have it provides you the mechanism of online data creation, physical data download, or the data in the form of a web service also. So all the three modes are there. Let us try to understand let us try to see how we can access the data in those all those three forms. So for that you have to just click first this Bhuvan 2D over here. Now in the Bhuvan 2D, I will try to I will try to create some data sets in the online mode from the existing satellite data sets. So if you see it here, once you click the 2D, this map will be visible to you. Now here there are multiple options here. I click on the satellite, so it will show me the satellite data set. So there are some gray, so these orange color boundaries are also visible. You can switch them off just by clicking this less and then Bhuvan and cadastral boundaries, and in the more options they are available over here. Just switch them off, so only the satellite data is visible to you. Now this particular satellite data is from one of the Indian satellite that is known as resource set. In resource set we have one specific sensor called AWIFS, okay, that is a 56 meter spatial resolution satellite data. So entire mosaic has been created and it is published over here. If you see what is the season of this data, if you see this is the satellite name is ResourceSat 2, and at the bottom right, if you can see the exact source and the time stamping of this data is given. If you see here ResourceSat 2 AWIFS 56 meter spatial resolution, and this data set is of 2020. This current year data set is only over here. Month is not written because this mosaic has been created from multiple scenes of different months actually altogether. That's why it is only 2022. Now let me go to our city over here, Dehradun. Let me try to take here, zoom this part, or you can type the city name over here. It will zoom HRADUN, Dehradun, and if you see all things are visible to over here. So I will say Dehradun city post office. So this is your Dehradun city over here. It has directly zoomed to that part. Now if you see, now the current data which is available to you, this is ResourceSat 2 list 3. One more sensor is there in this same ResourceSat data by the name called list 3, that is of 24 meter resolution. The earlier one was of 56 meter, this one is of 24 meter, and this data set is also of 2022. Now you can further zoom it. This is again list 3 only. You further zoom it. Now this is high resolution data of 1 meter. Okay, this, if you can see, this is one small, I am identifying it over here in this city of Dehradun. There is one place here, and then let me go to move to our institute itself. This is one parade ground over there. This is one road here. This feature is particular road feature. We call it here at Rajpur Road, and similarly there is another road coming out of from this. This is called a New Kent Road over here. In your place it may be a separate name, and from here we reach to this particular institute. This is Kalidas Road, and this is your Indian Institute of Remote Sensing. This is, if you can see it here, in 1 meter data is also available in Bhuvan Geo portal nowadays. Okay, so that can be utilized for a wealth of data creation over here. Now if you can see here, I can create those building footprints from here as well. Okay, this is one building over here. This is some main building here, and this is your auditorium building in IIRS. If you can see, these are the roads. These are also clearly visible. So this particular data repository is providing the data in 1 meter resolution as well. Okay, and these data sets are ortho corrected as well. Ortho corrected means they are corrected with respect to the terrain also. So whatever measurements you are making on top of this particular platform or this portal, they are true to the ground. Okay, so my interest is, now I want to delineate the boundary of IIRS, and I know that this is the boundary of IIRS here. If you can see, I am moving my mouse over here, and I want to delineate this boundary. So how to delineate this boundary here? I am creating some data from here, tools. Then you can say here draw tools here. Once you click the draw tools, it will show you some options over here. Now since my boundary is a polygon boundary, okay, this is the boundary, so I will take the option called polygon over here. There are other options also like line and point, but I am interested in a boundary, so I will just click it here, and I will start from here. You can just click it here. If you see here, I am able to digitize, I am able to create the vector feature on online platform as well. Now if you see, you just click it over here, or I will just give you one hint over here. You just finish it over here, double click, and that boundary is finished. But my boundary is up to this part, so I was facing some problem while digitizing. So I thought ki there is another option. You can put this layer in edit mode. Once this data is in the edit mode, just select it. You can see these nodes are visible to here. Now it becomes little simpler for me. I am just moving this node rather than clicking. I am selecting this node here. You can see here, this is one node. Just click it here, another node is created. Just click it here. Now rather than digitizing, I am using these nodes as the method for creating these boundaries. So it can create it like this. So these are again tricks and tweaks which can be utilized by upon continuously using different online tools here. So if you see it here, I am just clicking, selecting this boundary over here. This node because since this boundary is known to me, that's why I am able to download. I am able to extract it so precisely over here. So we can do it up to here, this part here, this part here, and this part here. If you see it here, it is coming up to this portion. You can just simply, I will draw it over here, not take much time to it. Basically select it here, and this boundary is over here. This is again the boundary of your institute here, and it is from that side, it moves to this section, to this part here. So if you can create it like this, so it becomes simple for me. So here again, this boundary, this tree's boundaries, I am able to find it out. Since this is known to me, so I am able to digitize it here. The exact nodes, you can just see it here. You can move it here, and then once it is done, let me try one more, two, three more points over here. So your polygon boundary is over here, done. You can create it, you can make this curves also over here, so it will done. So just click it out, switch it off this editing mode, and your boundary is done. So this is your boundary of IRS, which we have just digitized from Bhuvan Geo portal. Just I will one node is creating over here. Let me correct it here also. So this is the boundary here. Now this boundary you can download also. Select feature. I am just clicking it here, and you can give some name to it. This is the first attribute is name, and what is this name? Basically you can say it is IIRS, and then create it. And then once it is created, you can simply download it. So your data is now downloaded. Let me go to the folder here. Now just copy it here. I will create one folder for the data set. Let me create it in the D drive here, new. I am creating one folder called demo. Open Geodata repository 2022. One folder I had created for my practical exercise over here. Control V, and then here you can extract it. You can say this boundary is created, extract to this folder. So you can see this is downloaded in the form of a save file. So these all the 4 files are required for it. So if you open this in the QGIS, it will also, since I have created a separate boundary, it is not the boundary of FRI, this is some other boundary. So we will try to see it here. To open this data, you can simply go to this downloaded repository dataset and drag this save file .shp. This file you just drag it here, and you can see this is your IRS boundary here. how it looks in OpenStreetMap. You can just select, this is your OpenStreetMap, and this is the boundary which we have just downloaded. You can see almost it is mapping there, matching there. So this is one data set. Similarly, we can create another other features as well here from here. Other features like we can create the polygons. It is already downloaded. I can then remove it from there. This building footprints we can also create. We can create this roads also in the same fashion by using this features of line over here. Point feature, only one point I want for the building, then we can also use this point feature here. Just click it here, select it, and then give some attribute to it while downloading the footprints, this particular point data set from there. So this is one way of creating the data in the Geo portal. Another method which this Geo portal provides you, that is physical data download here. So if you see here, there is another option called Open Data Archive. So just go to Open Data Archive, and here if I select one satellite, we have seen resource set 1 and 2, list 3 data I want. Just click on this resource set list 3 data set. Resource set is a satellite, and list 3 is one of the sensor whose spatial resolution is 23.5 meter. Now here again we want to go to down data of Dehradun only, Dehradun, select it over here, then it will zoom to that part. It is somewhere here only. So again I will just select it here, Dehradun, 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 and let me search it here. It will search the city for you. Yes, this is the city. Just select it here, and once it is searched, it will zoom to that portion. If you see it here directly, I will just move. It is taking some time, so let us move directly to this part here. This is your Dehradun, city of Dehradun. Now here I want to download this list 3 data set. This is the city of Dehradun, and if you see, it is coming in 2 scenes. So I required both the scenes, and then separately we have to stitch them together. Okay, so how to download this scenes now, and which is the scene? If you can just go here, interactive drawing, start, and you can just draw start it here, and then one polygon you can small draw here. So it will select these 2 polygons. Okay, and then you can say next, and you can see the list 3 data for Dehradun city is available from 2008 onwards. If you can see, first it is showing H43L15, and another seat is H44G03. The 2 seats are there. So first it has listed this one, and then the G403 is also listed over here. So now the data set is available from 23rd October 2008, 11, 12, 13, 14, 14, and then again of 13, 15, 16, 17, 18, 19. It can just keep on seeing it here. The data is available up to, you can see, 5th April 2019. I want to just see it here, view. So it shows me this is the data sets. Okay, so here it is showing a small portion of that city. This is showing on the left hand side data sets, whereas I want the right hand side data set, that is I want this G03. So you can just see here at the end it will come 5 April and view it. So this is the city over here. So this data for 5th April 2019. So both the scenes I want. Now I want to download the data sets of 2008, not 19. I am interested in the older data. So just select this 23 October 2018, and you can just one data is this, the other one is this 2008 data. Basically I want it. So 23rd October for H44G03, and similarly for H43L15, 23rd October. These 2 data sets I want. You can just scroll over here. The download link is here, but before downloading it will ask you to log in. So let me log in also. You have to register yourself over here for downloading the data sets. So it is a single sign on here. A very simple process for registration. You can create as a new user and then register. An email will come to you, and once your email is activated, your username will be created. I have already created for me. So I will just download and I will try to use my login credentials. And then login. Okay, so you can see I am logged in here. Your username will be displayed at the top right over here. Now you download the data sets one by one. So two data sets I wanted, 2008 data set. Click here, download. So your data is getting downloaded. The size is very simple. Again, you can select the another data set which you have selected. That was this one. Again, you can download it here. Download. So it will download. Both the data sets are getting downloaded. Now you can just check this metadata also over here. Okay, what is the what is the size of one grid basically over here. Thus you can check it from here, grid, and if you see it here, it is showing you the upper left corner is 78E and the other one is 78.25. So and this is 30.5 and 30.25. So your one tile is of 0.25 degree. So 0.25 degree by 0.25 degree. You can just convert it to your meters, so you will get that data sets also. I am not converting it, you just try it yourself how much it is there basically. I have only told you 0.25. 0.25 means around how much? It is around 15 degree, 15 minutes basically, because it is 1/4 of it only. So 15 minute by 15 minute is one particular tile. Okay, so once it is downloaded, now let us go to here. So in the folder, I will just copy these two files here. Control X. We had created one folder for our exercise. Let us go to that folder here, and if you go here, this is down E drive basically, E drive here. Then we had just created, that was demo, and then you can just paste it over here. Now right click here and then extract to this first one and select the other one also, second one, select it, extract it here. So if you see here, both the data sets are downloaded now. First is for H43L15 and another one is H44G03. Both are of 2008. Okay, now you can visualize it. Double click here. Your QGIS portal is already open here. I will switch off this OpenStreetMap from here. And this data set you can see here, they are available in 3 bands basically. 3, so 4 bands are there. This is green, this is red, near infrared, and the SWIR band. Okay, so for the list 3 bands over here. Now if I zoom to layer, right click, zoom to layer, if you can see, this is one data set. This is band number 4. This is band number 4, that is infrared. This is band number 3, this is the red band, and this is band number 2, that is the green band. So you can see the variation in the features as well here. But I am seeing only the black and white image. I want to see the colorful image. So for that also, you just go to this raster, and then here it is miscellaneous, merge. Okay, and here you can just select these 3 bands. Simply select 2, 3 and 4 here. Okay, and then we can say okay here, parameters I will give okay, and then you can say place each input file into a separate band. Just switch on this one, and the data type you can just select. I know it is unsigned 16-bit, select unsigned 16-bit over here. From metadata I have seen it. Then output file, let us create one safe output file here. I will go to this D drive here again, and then we have created one folder, demo, and then this data set is of H43L15. So I will write it here as a TIFF format we want here. TIFF format, this is, you can see here, TIFF form, GeoTIFF basically, GeoTIFF here, it is visible here, TIFF. this file. Okay, I will just check it here. We can create it as let us create it another format is there, TIFF file. Okay, select this TIFF file here, and then output I will give to it NH 43L15. okay, and this is of 2008, October 2008, OCT 2008 data sets. Okay, so it is save it here, and then we can run. Now you see your data set has converted into a colored image. Right click here, and then we can change the properties. Let us convert it to a false color composite. Symbology here, and then we can say here 3, 2 and band number 1. I think that might have been told to you also. This is your false color composite of the Dehradun city. One of the scene we have created. I want the other scene also. So for that also a small processing I am trying to make you understand over here. Yes, and then let us take the other band as well. That is over here. The other scene we were having. The other one is this one. Here also we have 3 data sets are there. Let us try to take those data sets as well. 2, 3 and 4th band. 5th band I am not taking. So if you see it here, it is going to the right hand side of that image this way. Okay, so right click here, zoom to layer. So these 2 scenes are required. This is again in black and white, so just convert them. Also that is NH44G03 raster, miscellaneous, and then merge. Okay, this option is there. Select band here, band number 2, 3 and 4. Okay, then once it is selected, then only these 3 bands are required. Okay, and then again I will say unsigned 16-bit for it. And then let's try to save to a file. So here it was NH43L15. So now this one is NH44G03. okay, G03. We give the name also here. It is OCT October 2008, but the separate scene, a side by scene only. Okay, save it here, and then we can run. So I have selected one parameters. Place each band into a separate band. This one you need to select, then you run it here. Okay, process error code 1. So I think some error it is created. Let us try to understand it here. I think it has not created. Save to file here. So NHG03, I will put version 1 v1. This is required basically. Save, and then place each band input file into a separate band, then run it. Now you will get that data set. Both are in colored image here. Now I want a single. If you see it here, this is one band, this is another band. Properties here, we can change it to 3, 2 and 1. Apply and okay. So a single scene, but I require one single scene. So for that also it is as simple here. Raster, extraction, miscellaneous, then merge. Select both the scenes. Those 2 scenes you have created. First one was this version 1, and this is L15, 43L15. Both the scenes I am selecting, and then okay, and then again it is unsigned 16-bit. Output file name you can give here. That is now Dehradun, HRADUN, Dehradun underscore 2008, and it is list 3 data, LISS 1, 2, 3, list 3 data sets. It is saved file, and then you can say place input file into a separate band. Select it here and then run. So if you see it here, your image will be created now as a single file. So this way you can create your small data set downloaded, and how to use it, how to process it also. If we have created one band over one this color composite, and then we have tried to merge them together, stitch them together. So the same one method is there, that is called merge. So this is also done. Now let us try to see one more method in Bhuvan Geo portal itself. The third mechanism, that was the online creation, physical data download, and the third one is data as a service also here basically. So if you can say maps and OGC services are available over here, I will go to this thematic services here. In thematic services, let me try to take land use map of 2005 and 6 at 50,000 scale. So select it here. I will select one state here, Uttarakhand, and then view. So the land use map of 2005 and 6 is visible to me. Now I want to use it in my QGIS software. So for that, the option is available here. This data set is available as a WMS also, Web Map Services. So just select it. I cannot download this data, but I can use it in my software. So select in Web Services over here. If you see it here, there is one URL over here. Just you have to nothing. You have to just select this URL. This URL makes all the magic over here. Control C, and then I will say layer, add layer, and now here you can see add WMS layer. Just click it here, and you just give one name to it, new. I will create one new name, BHUVAN, Bhuvan, and then URL is this one. Okay, and then once it is done, then you can just say OK, and then connect it. So once you connect to this Bhuvan Geo portal, all the layers which are available there, they will be available for visualization to you over here. So this is, it is showing over here. Now you can select your data set, layer name. What was the name of the layer? Let me check it from here. The layer name was LULC, this one, LULC 50K0/0506. Just select it, copy over here, and then you can go it here and search it here. Control V. So this layer it is showing. Select it and then add. So your data will be available to you over here in your portal. You see this land use map is for the entire Uttarakhand region is visible to you in your QGIS portal as well. In Dehradun region, you can see it here. Entire city is shown as a red part. It is an urban land. So it basically it shows you the legends also. If you see it here in the option over here, right, just expand it, then you will get the legend of these layers as well. Red is built up, then built up rural, all the things are available here. Apart from that, you can also perform a small analysis on top of portal here itself. Like I want to analyze the land use pattern of 2005 and 6 in over the region of Dehradun. So what you can do here, one option is there called analysis, and then draw AOI. You just small AOI. Let's just try to do. Select it here like this, and then analyze. So it will show you the analysis. This cropland is 56.04 square kilometers, and urban land is around 54.22 square kilometers. Just remember it. Now 54.22 square kilometers. Now let us see the same thing for 2015 and 16 land use map. Just click on this 2015-16 land use map. Again we go to the same region only, ki how much area has changed or increased. It is Uttarakhand here, view, and our boundary is already there. So we had created the small analyze, you go and then analyze. So it will show you cropland is 36.59 and your urban land is now 85. In 2005 and 6 it was something 52, now 54 square kilometers, but now it is 85 square kilometers. So it has changed over there under this boundary over here. So a small analysis we can also perform online itself. So this was one small demo on Bhuvan Geo portal. There are other options also. You can have a 3D Bhuvan as well. You can visualize the data in 3D mode as well. Just click it in online mode itself. Just click over here, and then what you have to do, just middle mouse button, click it, and then press that middle mouse button and move your mouse. So it will convert to a 3D domain over here. Now some layers are visible over here. Home, you can you can go to the layers option over here, and that can be administrative boundaries can be switched off. Now here you can just see here, okay, this is one 3D visualization of that. Now this 3D visualization you can save as well as a movie format. Okay, So there are options here like record and play, so that can also be performed. So these are some of the advantages of open geodata repositories. So this is two examples I have shown you of OpenStreetMap and Bhuvan Geoportal. Apart from that, ISRO has also developed one online portal that is by the name called vedas.sac.gov.in. It is basically visualization of the Earth observation data and archival system. It also have a wealth of data sets like satellite data visualization, NRT, near real-time data can be visualized over here. You try to explore it yourself. Vegetation and crop monitoring, desertification and land degradation. So you can also perform time series analysis using this portals. Like you can see here, vegetation crop monitoring, new energy renewable, air quality monitoring. There are multiple things are available. Many thematic applications. The data for various thematic applications have been published in this particular portal. So you just try to explore it. I am not going into much detail of this particular portal. Maybe some next time I will select this portal itself for the demonstration of the data sets. This is very useful portal, and another portal I will I will just give one small overview of that one. That is the ISRO Science Data Archival. So if you are interested in some interplanetary research, that Chandrayaan satellite, you may be aware. Now I want to visualize the data of Chandrayaan. I want to see how the data looks like. And if I have the capabilities, I have the tools with me, but I don't have the data set with me, there are numerous softwares which can read this data set from proprietary side. This is IIRS Imagine or NV or from SAC also. If you can see it here, this official website, we have satellite data as well also here. So that can also be downloaded from various ISRO websites wherein these data sets can be visualized. If you see here Chandrayaan 2, I will just click it here. Now it also allows you to download the data from the surface of the moon. In this particular, now see, if you see it, some details is given over here. Chandrayaan 2 orbiter is currently in 100 km by 100 km orbit around the moon, and it has 8 experimental studies for ranging from surface geology, composition of exosphere in measurement, and it will continue to build upon understanding from previous lunar mission. What are those experimental studies ranging? Let us say first one is the Chandrayaan 2 large area soft X-ray spectroradiometer. This is one instrument which has been placed in that particular orbit of Chandrayaan 2 in that satellite. Similarly, we have solar X-ray monitor, XM, image infrared spectroradiometer imaging, infrared spectroradiometer is there. The dual frequencies synthetic aperture radar data is there. Orbiter high resolution camera is there. Terrain mapping camera. So these are our photographic cameras as well. And this is Chandra's atmospheric composition explorer 2. This data set, dual frequency radio services. So these all data sets are directly available as a download from this portal. We call it as pradhan.issdc.gov.in. You just type it in the Google, Pradhan and ISRO, the same website will be displayed, and from here browse and download. You can download this moon surface data set from over here. So apart from this Chandrayaan 2, it also has a GRASP, basically GRASP data set. This is a geostationary radiation spectroradiometer. It has one instrument to study the energetic particles environment in the geo orbits. So in those particles which are available in the geo orbits, so for those can also be studied, and these are required because our satellites are lying in that particular orbits, and these particles are continuously moving over there. So sometimes they degrade the satellites in that orbit, so they need to be studied. So that's why this particular instrument is providing the provision, the facility to read those energetic or the charged particles for taking necessary actions. So this was Chandrayaan, and one more is there, the weather data. Now another portal is there, that is from MOSDEC, mosdec.gov.in. It is a meteorological and oceanographic satellite data archival center. So this particular center is also providing you the data sets from weather, for the data set pertaining to the weather information. Now, not only the data sets for the near real time, the cloud data, the humidity, surface, rainfall, temperature, all those data sets are available in this particular portal in the near real time. Most of the data sets are in the experimental mode. You can explore these websites further and see how you can utilize these data sets. One important which we have used it, access data. This is open data over here. So forecast data is also available there. So these all can be downloaded from this portal and can be utilized for any scientific research studies or any operational data studies as well. So these are some of the portals. Let us come back to the slides here. So apart from this ISRO portal, there is another example from NASA as well, called as a Earth Explorer. This also provides you a wealth of data sets for downloading. Satellite data from the foreign satellites, it can be hyperspectral, the radar data or the optical data. It has a provision for and that too in the temporal mode. Let us say from 1990 onwards, the data set is available in this particular portal, and you can just try to explore it and download the data from there and use it for your research studies. Similarly, one new portal has come up that is called this is EOS from the EOS. It is also providing you the different kinds of products as well, like NDVI products, color near infrared, forest coverage. So just try to explore. This is EOS viewer, you can say it, EOS viewer, or we can also sometimes we are calling it as a land viewer. This is a proprietary. Some cost is some of the data set is freely available, whereas if you want it for some proper quality data from this particular portal, then some cost you have to pay for it. There is another socio-economic data also is available in the form of a web services, that is from the socio-economic data and application, CDAC, SEDAC. So it also allows you, if you can see here, for example, village level geospatial socio-economic data for the state of Uttarakhand, means village boundaries are also available there along with the census data. It is available in the WFS format. You can directly open this WFS format in your QGIS software, which just I have demonstrated you over here. So these are some geo name API. Suppose your lat long information you are having and you want to know what is the city near to that place. So that based upon the postal code, if you want to find out the name of the city, so these are available as a web service. You can download the data in JSON. You can see the data in JSON or XML format. Or suppose I want to find out the elevation data at a particular latitude and longitude at a particular location. So that can from SRTM, from ESTER, GTOPO, 1 kilometer data sets. So these all can be explored. Try to explore this GeoName as well. It is basically providing the data in the form of an API or in the form of a web service only. So with this, I believe I have covered. I have given you a small demo on various kinds of what are the various types of what do you mean by a geodata repository or open geodata repository, what are the challenges with it and what are the features for it, what are the various modes of data download, and a few examples I have covered up. I hope I will be leaving this these slides also. So a list I have created wherein you can explore this list so that any kind of data set you can see from here, like wind climb, open topography or geo network. So along with the URL I am just leaving over here, and you can use it for your research or any other project work. So with this I come to the end of this slide. Thank you very much. We will wait for some 2 minutes, and after 5 minutes I will take some questions as well. Thank you very much.